Welcome back to part 2 of the discussion Matt and I are having about the Build HD standard and the 100 to 500 year home. So we talked last time about all the elements of planning through the structural planning components and all the considerations that we had in designing a good, solid, durable structure.
Yep.
And we touched on a little bit about the envelope or the enclosure and a little bit about mechanical systems. But let's go back and more specifically talk about what are the elements of those improvements, right? So in the envelope, we worry about our 4 control layers primarily. Water,
what are they?
Air, vapor, and the thermal heat transfer through the envelope. So what are some core things that we can do to make those individual enhancements to make the home more durable?
Yeah, I mean, let's go back to the water one, Tim, right? We think this is 80% of construction defect is water related.
Right.
So I always love the umbrella example. You know, modern houses don't have an umbrella. And more traditional houses maybe even had a golf umbrella.
Right.
And if you're a traditional house with a golf umbrella, does it really matter if you have a Patagonia jacket on to keep the rain out? Because the umbrella is doing the yeoman's work of keeping the water off the structure, right? But if you don't have a golf umbrella, you don't even have a totes travel umbrella, you only have a Patagonia jacket, and you've got your hood up and you're zipped up to the top. Can you hear the zipper on the podcast? That's my quarter zip. If you're zipped up to the top, and you guys can picture me huddling here with my Patagonia jacket, I better have a pretty dang good jacket on to withstand the weather. And so the analogy that we like to talk around in the office here is like, look, you're going to build a modern building, no overhangs, parapet walls. Man, that's a Patagonia jacket that you better spend not just $500, but like assume you're going to Mount Everest and you're going to get the $1,000 Patagonia jacket.
It's not a Patagonia jacket, Matt. It's a dry suit.
Yeah, that's right.
You need to assume you're going to be diving.
That's a great point.
30-degree water.
That is a great analogy. I like that.
Because that's the kind of exposure your house is going to have.
Yeah, and how much more expensive is a dry suit than an umbrella?
That's a lot.
It's a lot,
yeah,
right?
Right.
And honestly, if you're building a really very modern house, you better hire a really stinking good builder who's expensive. You need really expensive materials, and you put them on with really good craftsmen who know what the heck they're doing. If you don't have expensive labor, expensive materials, and probably an expensive builder, and you're going on cheap for any one of those, you are setting yourself up for failure on that.
That's right.
So we're saying, instead of doing that, let's go smart to begin with, and let's keep the water from not touching the building to begin with by planning for a house that has a pitched roof and that has overhangs. It's as simple as that.
Right. There's so many fundamental things that you can do in design that make your house more forgiving and more resilient. And so just as you say, a decent overhang, 2 to 3 foot overhang all the way around your house makes a huge difference.
Yes, it does.
Right? Minimizing your roof penetrations.
Huge.
Don't have a lot of vents and pipes sticking up out of your roof because those are hard to flash, hard to overcome, especially with low-pitched roofs, right?
100%.
In design, minimizing the number of windows and windows and doors you have relative to the total exterior wall space.
Mm-hmm.
I think there's a good ratio to try to keep below 25% of all your exterior walls should be windows or doors. Anything less than 25%, the house will probably perform well. Many modern homes, they try to push that 50% window to wall ratio.
Or the all glass house.
Yeah, it's not only hard to keep the water out, it's hard to keep the air out, it's hard to keep the sun out. And
bugs.
And it's hard to manage the thermal transfer, right?
Totally.
So it's just listen, there are great ways to aesthetically place windows and doors where they bring the outside in without making your house vulnerable to all those bad performance things.
100%. I'd even add on there, keep your roof pitches 4 or 5 and above.
Yeah.
Out of 12.
Yeah.
And on my personal build, I have a roof pitch above my master bedroom, which is like a 3 or 4 and 12. And it works. I haven't had leaks, but man, it's so hard to get in there and service anything because it's like crawling around.
Right.
And I'm in my 50s. I don't like to crawl on my knees, right? That's a young man's game. Yeah. I don't even like going in to change the filters in there because it's painful on my knees. Right. Whereas my other attic originally was going to be that same like 4 and 12. And we did a cross section of it. And I realized, oh my gosh, I can't even stand up in my main attic where I'm going to store things, where I'm going to have my HVAC equipment. And we bumped it up with the architect to 7 and 12.
7 on 12, I think is what
my
it is.
main roof.
Yeah.
And it's wonderful. It's perfect. Did it change the architecture a little bit? Sure. Do I care? No. It's way better. And also it sheds the water really quickly.
Yep.
And that matters, right? When you have a slow draining roof, we have more time for that water to dwell and to potentially over the years break down your flashings, break down whatever, and get into the house. So a higher pitch can be really beneficial. And I'm not advocating we do 12 pitches. Those are terrible for the roofers.
Yeah.
But do it if you need to.
6 to 7's great for a lot of different things, not only shedding the water, but also creating great mechanical space, serviceability.
Yes, serviceability.
And I think in your case, your attic is generous enough that you can go up there and use it for usable space. Like, don't y'all wrap your gifts in the attic?
My wife has a gift
time?
wrapping station. My son had he was into the Rocky movies for a while, and he had a punching bag up there he was using. Yeah. My attics are amazing. I love them.
Yeah, that's great.
They're a great space.
Yeah. Okay, well, let's talk about some other key things, proper flashings that we can design, kick out flashings, head flashings, slope sills when we install our windows.
Yes.
And then, of course, we always have to have rain screens behind all of our claddings.
Yep.
I like to assume that all claddings are going to let water through.
That's right.
Right? Whether they're reservoir claddings or siding or whatever, they're all going to let water through somewhere.
That's right.
So we just have to realize that and say, okay, water's getting through. How does it get out? How does it dry out?
100%.
Right? And that's baked into the design, the enclosure details.
And this isn't all about the Build HD standard. This is kind of backing up towards it. But in our Build HD standard, which really Tim did the majority of the work on, I think we say if you're in a climate zone that gets more than 20 inches of annual rain, you have to have a rain screen on that cladding.
Yeah.
It's vitally important.
Right. If you live in the desert where you get, 10 to 20 inches of rain a year.
Okay. No big deal.
That just is baked in forgiveness because your house is not going to be exposed to that much bulk water. Right.
Yeah, exactly.
So it works pretty well. But a lot of the country, if not most of the country, doesn't have that luxury. Right. We have to assume that we're going to get exposure.
Do we actually say that? I'm tangenting here a second, but on the flat roof thing, do we say you can build a flat roof if you're in the desert, but you can't anywhere else? Like, do we have a 20 inches of annual rainfall or not? Kind of caveat on the
I think we
HD
talk
standard.
about it in some aspects. I'm not sure it speaks to flat roofs or pitched roofs.
Can't remember.
But certainly we know if you look at historic architecture in the desert, most of those do have flat roofs, right? Or some very low pitched roof because it doesn't matter, right? When they do get a rain event, it's usually not heavy enough to overcome any flat roof mitigation that you have baked in through parapets or whatever. So you can get away with a lot when your rainfall is that low.
Yeah, that's right. Yeah. Should we move on to MEP?
Yeah, let's do. I think, that's my passion, right? As you know, I love.
You are a mechanical engineer by schooling.
I would say that the understanding of what each of those mechanical components does is something that our industry really doesn't do a good job of.
Yeah, that's right.
Right.
Yeah.
We're so used to just relying on air conditioning equipment to do everything, and without realizing that the more we manage the enclosure, keeping the water, the humidity out, the air out, the more important it is to have a robust, I don't want to say complex, but integrated mechanical system is key.
Yeah.
Not only do you have to manage temperature, you got to manage humidity, you got to manage the quality of the air, keep it fresh, keep it filtered. And whenever you do ventilate, you got to realize that when you suck air out, you're going to bring air in, so you might as well manage the air that you intentionally bring in. So 4 different things to think about in the mechanical systems, and they're all just as important because they have to be integrated together.
Yeah, that's right. For sure. Boy, there's so much to talk about on this one. This could be a whole separate podcast on this topic. Give us a couple bullet points in the mechanical phase.
Let's assume that everyone knows what air conditioning equipment is. The old one is like it's on and it's off, and it just comes on when the temperature needs to be adjusted. Nowadays, we have this whole array of air conditioning equipment that manages controlling the temperature by different methods of refrigerant flow. Some of it is a multi-stage, some of it is a variable stage, some of it is infinite variable stage. Yep. So now I will say that there are some of those that manage what we call latent environmental quality better than others. And that generally speaks to how well the air conditioning system itself removes the moisture out of the air, right? That's the latent component of heat transfer, is removing the moisture. Now, that being said, the more intricate air conditioning systems, the VRF systems, don't necessarily do a very good job at latent control. So we need managed dehumidification, right?
Yep.
There are several different manufacturers who do that. All of them do it really well, but standalone dehumidification equipment, and I'm going to say at least one of those for every 1,500 to 2,000 square feet of living space you have is important.
Is that in our Build HD standard? We should add that. I like that. That's a really good. That's really smart, because we've made that mistake before by thinking that one big unit will handle this big house, let's say, but the air in separate areas of the house doesn't mix enough to let one unit do the duties for the whole house. And here's just a quick example. At my home, I have a 2-story house. I only have one connection between those 2 stories, which is a stairwell. And I'm so thankful I put a downstairs and an upstairs dehumidifier in, because they do run separately and they run at different times. And I can tell the difference, because I had one of my units die on me and I had to replace it under warranty, thankfully. But I could tell the difference, that it was really getting more humid in one of those 2 spaces. It was my downstairs one that died. Long story short, I really like that general idea of one dehumidifier per 1,500 to maybe 2,000 square feet. That's great advice.
There's a lot of other factors involved about how open your house is, or how discrete the different zones are from each other, and how well the air mixes throughout the house. So it's a general rule. We should more clearly define
Rule of thumb.
A couple of different ways to integrate dehumidification equipment. I like it to be standalone. Some mechanical contractors like it to be integrated with the air conditioning equipment.
Yeah.
There's a conversation to be had there, and we probably don't have time to get into that. But
we don't. I'm with you on that. I like a standalone too, but Sean Harris makes a great argument for integrating it that I don't think you're wrong either direction.
Right. I think you go either way.
Yeah.
And, in a complex custom home, you probably should have a mechanical engineer or a sophisticated mechanical contractor help you figure those things out.
That's right.
Right. So, that's one example. Ventilation we talked about, right? ERVs, HRVs are a thing in the country, depending upon what climate you're in. What that means is that's controlled ventilation that's filtered, but that it takes the thermal quality of the air that you're removing and transfers it to the fresh air that you're bringing in.
That's right.
So it's energy recovery. It's energy transfer, not just heat transfer, or not just air transfer.
Yeah, moisture as well.
Right. I think that's an important component, but it's not all you need.
That's right.
Right. And there's certain conditions where a standalone bath fan might be okay. Right. But in a complex house that has, a number of bathrooms, good sized kitchen, that you need to be thinking about how many people live there and what the moisture load is on the house and what the pollutant load on the house is. ERVs become much, much more important in those situations.
Yeah, that's right. Give us some durability upgrades for the MEP system that you can think of, Tim?
Well, I mean, there are common things. If the temperature extremes, we want to do frost-proof hose bibs instead of the old traditional hose bibs that we have to wrap or drain or drip.
Right.
That's not smart anymore. Even here in Texas, our temperatures get down in the teens on a regular basis now.
Yep.
So that's just one common thing. Wet areas inside the house, showers, tubs, any area that's exposed to lots of bulk water inside the house need to be managed well. Just assume that's another outside environment, outside enclosure that we're doing inside. So using cement-based products, not drywall-based products, using lots of robust weatherproofing membrane products in those wet areas is important. Detailing of all those wet areas is important. You know, how we put the glass in, how we put the curbs in, those kinds of things. Just common sense things.
What about on the electrical side? Can you think of some upgrades that are on the electrical side that maybe speak towards resilience a little bit?
Well, I mean, I like whole home surge protection. That's key nowadays.
How expensive is that? Is that a big upgrade?
It's not expensive at all. No,
is that right?
It's not.
It's not that big a deal.
Now there are some that are like super sensitive and super robust. That if you have a high end AV system or electronic
Macintosh
system
or whatever,
right? You better think about one of those high end multi-$1,000 surge protection systems.
Yeah.
But generally, something that can be mounted in the panel that just protects the general high voltage electric system from, overload from lightning strikes, for example, or surges is important. Lightning protection, if you can justify it, makes a huge difference in what your house is subjected to because those things really work.
Yeah.
And for $10,000 or $20,000, you can put it in a pretty complex one in a house.
Yeah, for sure.
Nowadays. And of course, backup power systems, right? Whether it's solar, batteries, generators, all the above, all those, because we can't rely on our power grid anymore.
Man, we could spend a whole podcast talking about backup power, but what's your, if you only have a limited budget, what is your go-to when it comes to backup power? What do you prefer?
Well, specifically for backup power, it's hard to beat generators, right? I mean, they're very reliable, very efficient, and they're a little noisy, right?
Yeah.
But they come on when they're supposed to, they go off when they're supposed to, and they require somewhat minimal maintenance. And they're generally a lot less expensive than a backup battery system or a solar system. There are other benefits to batteries and solar.
Sure.
Right? They save you on your monthly utility bills. They can be used, throughout the year. But for specific grid unreliability, generators are hard to beat.
It's really hard to beat. And there's two levels, too. A homeowner who doesn't mind being involved, I'm using you, for instance, for years, long before I ever put one in, you had a system that was the ultimate reliable budget system, which was a plug inlet on the outside of your house that ran key circuits. And you had a Honda, I don't know what it was, 5 or 6. 7,000 watt generator in your shed that you'd roll out and you could plug in. And, that's a really very inexpensive system to have the plug put in, and then you just got to buy a good generator.
Right.
When I added a backup generator to my house for the first time 5 or 6 years ago, which happened to be like 2 months before the big storm, I put in a $4,000 or $5,000 Champion 12 kW, I want to say it was, or maybe 10 kW. I can't think of the exact size. They're pretty dang affordable. They're really not that bad.
They're not bad.
And then my new home has a 14 kW, but now Champion even makes a 20 kW, which is still pretty affordable. I want to say it's only like $6,000 for that generator.
Right.
And then, of course, you can go to big units. Like we put a train engine on a job before that was like, what was that Kohler? Is it a 40 or 50,000 kW?
Well, we're doing one right now that's an 80,000 kW.
Yeah, that's
80 kW.
That's a train engine right there. It's a beast.
Yeah.
But, those do get expensive. But there's all those ranges. But having that backup power, man, that's really nice for resilience.
It is. Well, listen, I want to transition into something that is a passion of mine, and that's after we do all these things and consider all these things in the planning stage, how do we properly execute it?
Yep.
How do we actually build it?
Yep.
What are the things that we need to be doing to implement that plan?
Yeah.
So, because, I mean, think about it this way. Even if you had the perfect plan, if you'd done everything you're supposed to do, you got a great set of plans, you've thought through all those enclosure details, et cetera. If you don't implement it right, it's going to fail.
That's right.
Right?
No
So
doubt.
you have to make sure that everything you do throughout the execution is thoughtful and thorough.
Yep.
And if you're not the actual day-to-day quality control, you should have somebody on your staff that is.
Yeah,
right?
that's right.
And so every day, everything that gets done, you have to go to the job site with blinders on. And what that means is you're not looking at things that were done a month ago. You're looking at things that were done yesterday.
That's right.
Right? And you're scrutinizing those things to make sure they were done to perfection or near perfection.
Yeah.
And so that's the key right here is day-to-day managing your project so that everything that gets done is done to your standard.
Yeah.
Your expectations.
Right. That's right.
Right.
For sure. Boy, there's a whole nother topic on supervision there, but give us a couple of the pillars when it comes to inspection, documentation, testing, that sort of thing.
Well, I like to think that the plan is only as good as your ability to execute. And what execution means is that as you perform the work day to day, you're inspecting it, you're testing it, and you're documenting it.
Okay.
Right? Those three things.
I like that.
So inspecting means, as we've talked about, you're the quality control guy. When you get to your air sealing detail, you should have what we call on your staff an ASS, right? The air sealing specialist. Everyone needs an ASS, right?
For sure. You got to have an ASS.
We have an ASS on our staff, and he's really good at what he does.
Yep.
So I think that's important to have that scrutiny or that level of detailed attention to each of those different components of the execution.
That's right.
Testing, whenever we get to certain stages of the project, we have to test its performance before we do the inside insulation or drywall. Let's test the air tightness. Let's test the duct leakage.
Yep.
Let's test those things that we know at this point that if they fail later, it's going to be hard to get to later to fix.
Yep.
So 2 or 3 phases during the work, let's go through and test it. Let's test our windows to see if they leak. Close all the windows. Go outside with a massive hose and let's just drench the house before we put the cladding on.
That's right.
Let's make sure the windows and doors don't leak.
That's right.
Those simple things can make a huge difference.
Who was the famous president who said trust but verify? Was that Reagan? I can't remember if it was Reagan or not. And then, of course, my buddy, our mutual friend Jake Bruden says it a lot. It's one of his
I think it was one of our earlier statesmen back in the one of the founding fathers might have said that, but I don't remember.
But I love the phrase.
May have been James Monroe.
Right,
I don't know.
We hire good tradesmen, tradeswomen.
Yeah.
And we trust them, but we also verify. And it's not that we don't trust you by verifying. It's like I was at our job yesterday that has a fantastic air barrier between the house and the garage that was up. It was a solid zip sheathing that was up between the house and the garage, perfectly done between the trusses ahead of time. And I noticed that one of our guys, I'm assuming Mark or Will, liquid flashed everything through there, but the low volt guy had added some additional wires. And they hadn't been liquid flashed yet, right? And I'm not saying that I caught something. I'm saying, look, I trust our guys, but before we move to the next stage of construction, we need to verify that we got all that complete.
I want to say we've gone through 20 cases of liquid flash so far, and I guarantee you we'll go through another case or 2 before we actually do our air infiltration test.
Amazing.
Right.
It's watertight.
You continually have to go back behind trades because every trade has a massive amount of penetrations through the outside that you have to manage, right? Yeah. And it's just the nature of complex construction.
Yeah, for sure. At my own home under construction 4 or 5 years ago, I was super diligent and I was the QC guy. And at the end of the project, prior to installation, I had aero barrier come and tighten the house down. And I looked at it after air barrier is done, and the guy was like, "Hey, check those wires out right there. That you can see the big whitish marks that air barrier sealed that. You know, that's where someone missed the blah, blah, blah." And I was like, well, that someone was me. I missed that.
Yeah.
And I'm so thankful I had that aero barrier at the time, because I was kind of a one-man band verifying everything. And I'd looked at that more than once and never thought, oh, I need to air seal that.
Yeah.
So it's that trust but verify. It's so vital.
Right. Well, all that being said, I do want to say one other thing about testing at the end of the job, at the end of the project, when we're, let's call it substantial completion, right, for an industry term. We like to go through a process called commissioning, right? And, you know, we used to call this punch out, but it's so much more than punch out, right?
Yeah. Punch out is a drywall touch up and you know, some paint here and there.
Right. Commissioning is taking all the systems and components that we've integrated in the house and making sure that they work well together. Not only are the individual systems working well, that they're working well with other systems. So that integration of all those systems, not fixing things, but completing things, right? Yeah. Because those things that we go through and manage through commissioning are not things that were done incorrectly. They're probably things that are just not complete yet, because when the mechanical system was designed and installed, it didn't necessarily take into consideration how the electrical system was going to be designed and installed.
Right.
Once those things are put in and complete, now we got to figure out, do they work well together? What are the deficiencies that need to be overcome? That's commissioning, right? And so that's an important part of that final testing process. But all of that works well, but we forget it. And we don't have a good record that it was all done correctly unless we document it all along the way.
That's a great point.
So part of the execution is every day, document what you did. Take photographs, take notes, and then on a cyclical basis, once a week, report it. Report it to your peers, you know, your superiors, your clients. Report the progress and document the process. There's no reason in today's time that every day we shouldn't be taking 10 to 20 pictures of our individual projects every day.
That's a great point.
Right?
Yeah.
There's no reason for that. And then at the end of the week, go back and review those photographs and review the notes that you've taken, and then create a summary report. Share it with the team, because that's your step-by-step progress report on how you're doing. It's a self-check. It's a peer check to make sure that everyone's on board with how you're doing it, what you're doing, so they can see you're implementing the plan the way it was created.
Yeah, that's right. Tim, talk to us about the mindset shift that needs to happen when we are moving to this house that is going to be around longer than us.
I hate to wax philosophy too much, but I
like a little of that.
I
frankly.
do it on occasion.
I do like it.
I would say as builders, we are stewards of the process for creating the homes that we do. And so it's easy to design a home. It's easy to give that design to the trades and the suppliers and let them go about their tasks. But if it's not managed well, if it's not scrutinized on a daily basis and checked to make sure that it's being implemented the way it was designed and thought, then it probably will fail. And so we are that steward. We are that arbiter of making sure it's done right.
That's right.
And it's our ultimate responsibility. We can't blame the plumber. We can't blame the framer. We can't blame the people that actually did it. We can only blame ourselves for not catching it and making sure it gets corrected. So that's one thing. The second thing is that if we do it right, the homes not only they not only are a dwelling, but they become a legacy of our existence.
I love that.
So if we only live for 70, 80, 90 years and our homes are living for 100 to 200 years,
or 500,
long after we're gone, this home is a legacy of our existence on Earth, right?
Yeah.
And to me, that's my primary motivation for being a home builder.
I love it.
It's because this is something I'm doing that's going to outlive me.
I love it. So cool, man.
Right. So take that for what it's worth. And that's probably pretty mushy, but anyway.
I don't think so. I mean, I think there's been generations of builders before us that felt that way. And we've watered that down with a consumer mindset over the last couple decades. And I think all you're doing is bringing us back to that.
Right. I love to think of this as craft over commodity.
Yeah. I love it. Durability is intentional, not accidental. That we need to plan, design, execute, and verify that our small decisions compound into long-term performance. And a well-built home should outlast its original owner and well beyond.
Yep.
It's good stuff, Tim. Stay tuned for the Build HD standard to our listeners. We're dribbling it out. We're talking about it. But the full standard, Tim and I are doing a series on, videoing it. We're building 2 houses to that standard now. One here in Austin that's a Reisinger build project, and one that's down in San Antonio that will be a Build Show Live tour house. And we're still working on how to make everything public and how you guys in our listening audience around North America could get a copy of the full standard that should be available this fall on a more public release. This is designed by builders for builders.
Right. And I would say that to that point, it's important that as we roll this out, as the friends and colleagues that hear us and watch us understand more and more about the Build HD standard, we solicit feedback. We solicit comments, enhancements, things that you think we have left out, things that we need to think through more in depth. We're welcome. We welcome with open arms all those comments, right? Yeah. Negative, positive, whatever. Send us your feedback.
Yeah, as we roll this out, this will be kind of a 1.0 with the assumption that we're going to upgrade in the future and maybe at some point even have a 2.0.
Right.
Or a 3.0 or a 1.1, 1.2, and then a 2.0. We'll see.
Yeah.
But Tim, thank you for your leadership. You've been doing the bulk of the work on Build HD Standard. I know it's been a lot of late nights and a lot of early mornings. But I think that really speaks to your mindset of legacy. I think you and I both love building houses and have built some amazing houses, but we can't build every house.
That's right. But man, I don't want to say in response to that I have evolved and matured in the way I think about things and the way I do things. And a good portion of that is in response to your thought leadership.
Oh, that's kind of
so in the last 10, 15 years, as I have worked with you and observed you and been, actually, we've been together 20 years as friends and colleagues. Yeah. But just observing you and your passion and your, as I say, thought leadership.
Thanks, brother.
Is not only benefiting me, but it's changing the entire industry.
That's kind of
and I think our audience would agree that they look up to you. Your enthusiasm is infectious, and it just rubs off on all of us. Our colleagues are hearing now, and the way you and I have put this together is a result of that collaboration.
Thanks, brother. I think of you as my older brother, Tim. We've been friends a long time. It's been a lot of fun. Thanks for having me on the Reisinger Build podcast, dude.
Well,
more to come.